been a while since I played Monopoly. I'm actually a person who likes to compromise, and if somebody is very agitated and wants to be the banker, I will allow them to do so, but I will count the money as they do it. So. All right. Express the following equations in exponential form. Piece of cake upside down. Logarithms solved for exponents. This is the base right here, and this is the exponent. So therefore, yep, so it's 2 to the third power is equal to 8. So we're going to do half of these problems together, and then the other half you're going to have to take home and do on your own. So B, we have a base of 5 to the fourth power is equal to 625. So you should be able to write logarithmic expressions in exponential form. You should also be able to do the opposite. It says express the following equations in logarithmic form. So log with a base of 3 is equal to the exponent 2. So that's how I remember it. The base goes there, logarithms solve for exponents, and then the other number goes there. So this would be the log base 18 is equal to 0 of 1. Flip it over. Yep. 3, solve for x. This means 3 to the x is equal to 9. So therefore x is 2. What is the base for b? E. The base for b is e. E to the x power is equal to 1. What do you take to the x power to get 1? 0. X is equal to 0. Okay. Oh, sorry about that. I think this should be, no, that's right. Okay, let's look at h, something a little bit more difficult. 8 to the x is equal to 4. I'm going to write these both as a base of 2. 8 is 2 to what power? 2 to the third. So 2 to the third to the x is equal to 2 squared. So that means I have 2 to the 3x is equal to 2 squared. Okay, we'll try again. 8 is equal to 2 to the third, right? 2 times 2 times 2 is 8. And you see the x there. Power to power, you multiply the exponent, so 3x. Now they have the same bases. If the bases are the same, then the exponents are the same as well. So 3x is equal to 2. 5 by 3, x is equal to 2/3. Okay, well, g, what e to the 0 is x? What's anything to 0 power? 1. All right, number 4. This is what we are going to spend most of our time using in calculus, is problems 4 and 5. So the question is, what do you have to know about logarithms to be successful moving forward? Yes, you need to know about 4 and 5, probably the most important piece. And that's using the properties of logarithms in order to rewrite the expressions. When I say properties, I'm referring to these laws of logarithms. Now, I give you a various calculus notes worksheet not too long ago, right? I promise that starting tomorrow, you're going to have that out every day. Do you guys need me to reprint ones for you? Various calculus notes says all the derivatives on there, a bunch of other stuff. Do you have that? Oh, you didn't turn it in. All right, F. Fail. All right. I was wondering why I went through your stuff last night. I didn't see it. All right. So Allison has this. As you notice, I have put on there laws of logarithms. You see them? Laws of logarithms right at the bottom. So what we learned is that if you have a logarithm of two things multiplied by each other, you can separate it into two logarithms and use addition. Now, that may seem like complete voodoo mathematics, but it is in fact not. If you had x squared times x to the third, what do we do to the exponents? So this is the property that is happening. Okay, that's what it's trying to show you.
that you can, if you have two things times each other, you can rewrite it using addition. Because again, logarithms solve for exponents. So that's what it's relating to. So it kind of helps you out a little bit there. And division, you can rewrite as subtraction, and powers you can rewrite using multiplication, exactly like what we did last year. Now, your question will be what to do when. And this is the only way I can explain it. Doing my best, I promise. What's the first step to solving that equation? -1. The reason why is because you were trying to undo the order of operations. So think about it. In terms of order of operations, what comes first? Multiplying by 2 or adding 1? Multiplying by 2, and then you would add 1. So that is the first thing that you undo. Same thing in this expression here. As you are evaluating 4x over y, forget about the logarithm, but as you evaluate 4x over y, what do you do last? Is the last thing you do multiply, or is the last thing you do divide? Last thing you do divide. So that's the first thing we undo. We have the log base 3 of 4x minus the log base 3 of y. Now, because it says rewrite the expressions in form of no logarithm of a product, of a quotient, a root, or a power. So I have to get rid of some more pieces. I can't have this 4 times x. So I'm going to have the log base 3 of 4 plus the log base 3 of x minus the log base 3 of y. So I've now expanded the expression so it's not written as a single logarithm. That's my answer. I have multiple logarithms. There's no product, there's no quotient, there's no root or power. Let's try one that's more complicated. Let's look at D. Log of 3x squared cube root of 2y. So you tell me, what is the last thing I do? What's the last operation in simplifying this expression before I take the log of it? Yep, multiply by 3, so you can undo that first. Or you can undo the multiplication right here, right? Either one. I'm going to undo that multiplication piece first because I think most people kind of group together the 3x squared. So I'm going to write this as the log of, but Hannah, you could do either or, so you'd be fine the way that you were talking. Log of 3x squared plus the log of 2y to the 1/3 power. So I wrote the cube root as to the 1/3 power. Now let's look at this. The 3x squared. What's the last operation do? Multiply or power? Multiply. So therefore we need to undo the multiplication first. If you were to plug in a number for x, the first thing you do is square it, and then you would multiply by 3, right? So that's the first thing we undo. Log of 3 plus the log of x squared plus the log of 2y to the 1/3 power. We will in a second. So the log of 3 is good. Log of x squared. Yeah, the exponent can come out front. Remember that rule? So we have the log of 3 plus 2 log of x plus 1/3 log of 2 plus 1/3 log of y. So I did 2 steps for that last one. The 1/3 has to be attached to both because it's not just the y that's being taken to 1/3, the 2 is as well. That's my answer. Did you have a question? Log is a base of 10 if there's not another base. Natural log is a base of e, and e is a number, 2.7. So it's very similar to log base 2 or log base 3. It's very similar. I will show you tomorrow. Promise. It has to do with infinite limits. Thank you for asking. Okay, now we want to write as a single logarithm. So I don't want multiple logarithms, I want one. So am I going to use multiplication, division, or exponents for this one? Division. So I have the natural log of 120 over 4, which is 30. Natural log is the same thing as log base e. So I can rewrite this. I don't subtract the 120 and the 4, I divide them when I write from a single log. So instead of pulling them apart like I did before, I'm going to put them together. Okay? So what I could do is I could take these two, because they're subtraction, I could rewrite it as a single logarithm with division. Is that better? Let's look at D. I'm going to first distribute the 2. Now, let's try to have connects some pieces here. If you have negative exponents, are they in the numerator or denominator? Denominator. If you have positive exponents, they're in the numerator. So as you look here, I have subtraction. Since all these are negative, okay, these expressions will end up in the denominator. Since this is positive, it will end up in the numerator. But before I do with that, I want to move all the 2's. So now I have the natural log of 5 minus the natural log of 64 minus natural log of b squared minus natural log of a squared. Now, you see that they're all negative except for the very first one. So the first one will be in the numerator, 5, divided by the bottom of 64 b squared a squared, or a squared b squared. Is it still coming back to a little bit? Okay. So the 5, why don't we use the simplest number? 5 to the x is equal to 30. Well, the x is between what two integers? 2 and 3, because 5 squared is 25 and 5 thirds is 125. How we solve it? We use inverse operations. Then we take the log base 5 of both sides. And when I take the log base 5 of 5 to the x, these are inverse operations of each other. They'll cancel, leaving me just x. Do you remember how to find the log base 5 of 30 on your calculator? Well, I'm not just trying to solve those type of problems. I'll be later on trying to solve this type of problem. So yes, you've seen the most basic example, but again, if we said 2x is equal to 10, and somebody's multiplied by 1/2, you get a bunch of kids who'd say, well, why not just divide by 2? That's easy. Well, there are times where it's good to multiply by 1/2. So you can see that we're going to use this property to our benefit a little bit. Okay? So on our calculator, we do log of 30 divided by log of 5. So this is a change of base formula that you have on the front of your notes. What is the base in the problem I'm pointing to right now? What's the base as I'm typing in my calculator? So it doesn't matter what you change the base to, it'll be the same. So now I'm going to change the base to what? E. I change the base to E. You can see that I get the same result. It doesn't matter what you change the base to, it will be the same. So I get x is equal to 2.11. As I said, the answer will be between 2 and 3. Let's look at letter D. I have exponents on both sides here. Look, right? if I take the log base 4 of the left side, now I won't work out the right side, will it? If I take the log base 6 of the right side, I won't work out the left side. So now I see the log base 4 of the left side and log base 6 of the right side. I think I'll be good at mathematics, and it also work out nice, but if the program correct, you can find all lines of reason. So what we'll do is we'll do the log base 4 of both sides. Remember this thing from last year? All these things are from last year. Log base 4 of 4 to 2x, what is going to happen here? Well, cancel. Are you getting with? X is equal to if. You see the trick. Put it out there. Taking the 3 minus x and we'll drop it right in front. 3 minus x times the log base 4 of 6. Log base 4 of 6 is just a decimal, right? So I'll figure out what it is. Log of 6 divided by log of 4. Now, either natural log over log, that doesn't work. They have to have the same base. So 2x is equal to, we multiply it by 3, we get 3.88 minus 1.29x. We add 1.29x over 1.29x is equal to 3.88. Natural log 6 over natural log 4. So I'll just figure it out here. So now I take 3.88 and divide by 3.29. I get my answer, which is 1.1. So that's a pretty difficult question. The 2x equals 6 to the 3 minus x, and trying to solve that, I'll do a lot of guessing too. Trying to find it exactly, and then it's equal to x. So let's run the logarithm. Now we're going to go to the hardest part here, which you guys will look at this and just know the answer, because this is saying 3 to the second is equal to x, which is going to be 9. But let's not do that. Let's use the law of inverses and we'll solve this. I'm going to create a base of 3. As I create a base of 3, what happens here? I cancel over here. X equals 3 squared, which is 8. Okay, we just did that. It worked, but what would we do for J? And so they try to teach you the idea of apply it to a multiple problem. Now they put the J in the first write it as 1 logarithm. How can I write it as 1 logarithm? Divide, right? X over x plus 2. Now to solve this, I gotta get rid of natural log. How do I get rid of natural log? For the base of e, I was done. I got x over x plus 2 is equal to e to the third. E to the third is 20.09. I'll talk across side terms. Well, okay, no question. So, just thinking as it's going on. Over here, if you take into account, there's a second natural log, and a fourth one. So 20.09x just 40.8 is equal to x. We subtract 20.09 on the other side, we get 40.8 equal to negative x. And we take 40.18 divided by negative 19.09.